did that activity, you guys were going around the room doing those problems and graphing to review all the inequalities. A couple of you did not get that turned in yesterday, so make sure if you are one of those people, you get that to me ASAP so you don't have a 0 to start the second quarter. So the last piece that we are looking at in here is with absolute value inequalities. And so this really goes back to our and our or inequalities. We're going to be setting up these problems very similar. So our goal is to write this without an absolute value. And we have very specific things we have to do in order to do that. So is everybody on this notes page? So, big things you have to remember. If it's a greater than or a greater than or equal to, that is case 1. This will turn into an or statement. So, I always tell people to think great or than. These are ors. So, the first one, you drop the absolute value on both, so you keep everything the same. You just drop your absolute value. Or, for the second one, you drop the absolute value, flip the sign, and make it a negative. So if it's a greater or than, you set it up as an or inequality. One inequality is just what you had without the absolute value. Second inequality, you flip it and make it a negative. Less than, I always tell people think less than, those are ands statements. So great or is an or, 2 separate ones. Less than is an and. And what we do is we put this in between the negative and the positive. So when we're looking at our solutions, if it's a greater than or equal to 5, less than or equal to negative 5, the ors, we get 2 separate ones. The less than, we get everything between negative 8 and positive 8. It was an and. So it looks like this. Absolute value is giving you distance from 0. So when I say like the absolute value of x is greater than 5, I'm saying it's farther than 5 away from 0. So it can be bigger than positive 5 or smaller than negative 5. When I say the absolute value of x is less than 8, I'm saying it's within 8 from 0. So it can be anywhere from negative 8 to positive 8. All of those are within 8 of 0. Does that make sense? So our strategy on these problems, we always have to get the absolute value by itself, and then we will decide which of the 2 cases. So big thing, greater than, you do the ors. Less than, think and. So we isolate our absolute value first, decide which one it is, and then we'll solve our inequalities like normal. So let's look at that. So if I said the absolute value of x is less than 7. So first, is the absolute value by itself? Yes, there's nothing else on that side. So then, my next question, is this an and or an or? Less than and. So with the ands, we make one big inequality. say the negative less than x less than positive 7. All right, so when we set this up, those inequality symbols are both going the same direction. If I go to graph this, we know from the last several days when we have an and, what should our graph look like? Yep, they should collide. It's just in between two numbers. Open or closed circles? Open. So we would have an open circle at negative 7, open circle at positive 7. And we're just in between. The absolute value of x was less than 7. The distance from 0 was smaller than 7. So it's just the things in between those numbers. All right, number 2. Or. This is a great or then. Okay, so for ors, we make two separate inequalities. The first one, all we do is drop the absolute value. The second one, you flip your inequality and make this a negative. So, or we're expecting two pieces going opposite directions. So x is greater than or equal to 4, so it would be a closed circle at 4, going to the right. Less than or equal to negative 4 would be a closed circle at negative 4, going to the left. Are those okay? So let's start adding a little more to it. Number 3, is my absolute value by itself? No. Yes. So there's something inside the absolute value, but I don't have any numbers outside the absolute value. So once, if there's only an absolute value, we go ahead and ask ourselves, is this and or or? Or, great or, so that's an or. So, two separate inequalities. First one, all you do is get rid of the absolute value. Or, what do I do for the second one? We flip the inequality and make it a negative. We switch the inequality, we switch the sign. All right, now we just have two separate pieces to solve, but we can. How do I do that? So we get x is greater than 7. This one, if we add 1, x is less than negative 5. So x is greater than 7, open circle at 7, going to the right. Or x is less than negative 5, would be an open circle at negative 5, going to the left. Yes. Do you guys understand how we set that one up? So number 4, this one is a less than, so this is an and. How do we set up the ands? What do we do for those ands? Yeah, we make one big inequality. We put a negative 7 less than or equal to x plus 2 less than or equal to positive 7. So now we're solving this like we were doing yesterday. So negative 9 is less than x is less than or equal to 5. Negative 9 would be an open circle. 5 would be a closed. Our distance was less than a certain number, so we are in between those two. All right. I don't know. I didn't write down my equal to, did I? Thank you. I was just making sure you're paying attention. You passed. Any issues with those? on the back, I'm probably going to start jumping around a little bit. We're not going to do all of these. Let's look at number 6. How is this problem different? The absolute value is not alone. We have something with it. Before you decide if it's an and or an or, that absolute value has to be by itself. So how do I get the absolute value by itself? Add our 1 over. So the absolute value of x plus 3 is less than 6. Is this an and or an or? And. Less than and. So tell me what I write. No, it's okay. The next step. Yeah, except we don't need the equal to's because the original problem didn't have equal to's. So we say -6 less than x plus 3 is less than 6. So we just put it in between the negative and the positive. Subtract the 3 from all of them. So -9 less than x is less than 3. Open circle at -9. Open circle at positive 3. Looking in between them. Is that one okay? Let's go to 8. What do we have to do first on this one? We need that absolute value by itself. We currently have a -2 on the denominator. If you multiply by a negative, what happens in your problem? Okay, so I have the absolute value of 4x minus 8 is now greater than or equal to a positive 12. When you are trying to decide if it's an and or an or, it's based off this point when the absolute value is by itself. So this is a great or than, so it is an or statement. Or tells us 2 separate pieces. So we have this one, where nothing changes. Or, what do we do for the second one? Flip the inequality, make it a -12. Add 8, divide by 4. So the first one I get x is greater than or equal to 5. Second one. X is less than or equal to -1. Is everybody listening there? So when we graph those, greater than or equal to 5 would be a closed circle at 5, going to the right. Less than or equal to -1 be a closed circle at -1, going to the left. So greater thans, those are ors, they're always going to opposite directions. Less than is an and, it's always in between the two numbers. Those okay? Why don't you guys try number 9 for me? So if we add our 3, then we we have 10 times the absolute value of x minus 4 is greater than 50. I would rather not bring things into the absolute value, so like we discussed, you could divide by 10. So the absolute value of x minus 4 is greater than 5. So greater than, that is an or statement. So x minus 4 is greater than 5, or x minus 4 is less than negative 5. Add the 4. So x is greater than 9, or x is less than negative 1. Kind of ran out of space on my graph, but greater than 9 would look like that. Less than negative 1 would look like this. Does that make sense to everyone? Okay, let's do number 10 together, the very last one. One more where we have a couple steps. What would we have to do first? We have 1/2 times the 4x minus 4 is less than or equal to 4. Then, if I don't want to bring the 1/2 in the absolute value, what's the other option? Divide by 1/2 or multiply by the reciprocal. Multiply by 2. So any of those would work. So we get the absolute value of 4x minus 4 is less than or equal to 8. Is this an and or an or? Less than, and. So, the first one, we just drop the oops, I wrote that wrong. We put it, for the and, we put it in between the negative and the positive. So negative 8 less than or equal to 4x minus 4 less than or equal to positive 8. So we add 4 to everything. Divide by 4. So negative 1 less than or equal to x less than or equal to 3. So it's and, it's just in between the negative 1 and the